Hey guys, welcome back. Today I want to talk about a couple of Snap-on scan tools. Now over here we have the Apollo D9. I've used this in a couple of videos, but you guys don't see it very often because it belongs to the shop and it's normally shared amongst the other technicians. I have my own scan tools, so I typically don't grab this scan tool. But I do love grabbing the scan tool when I use it. It's very fast, very efficient, but sometimes I want a couple of extra features. Now, you guys have seen the Zeus in a lot of my videos. I've had it for a couple of years. We've done lap scope videos, diagnostic videos, etc. But over here is the new player, or the new updated version of the previous player. This is the Triton D10. So the Triton got a little bit of a makeover. It now has a 10-inch screen. Same screen design as the Apollo over here. It's got the new glossy black screen when it's turned off. The whites are bright. It's easy to see outside. The difference between this guy over here and the Apollo is the Triton has a 2-channel lap scope built in. Now there is a lot of similarities between all three of these tools. All three of these tools can access the Snap-on cloud, which means if you do any pre-scan, post-scan, or screenshot, those automatically get uploaded to the cloud. You can access those from any computer or mobile device. All of these tools have oil specs and resets built in, so I really like that because when you connect to the vehicle, even if you're just bringing the vehicle in for a loaf, it's really quick and efficient to do a pre-scan on most vehicles. Most of them are only a couple minutes long, so you can do that while you're checking the windshield wipers and everything else. But you scroll down, you hit oil specs and resets. It tells you what type of oil, how much, and how to reset that oil light. So that is a great feature that all these tools have. All these tools also have a section for the functional test and resets, which gives you common reset procedures. Certain sensors on the vehicle, certain relearn abilities, you have to go through many different modules to find that. Snap-on has started to group them all in one place, so they're easy to find. So whether it's an O2 sensor or a brake light switch, you may find that reset under that menu. Now the Apollo D9 I think is a great scan tool for any technician in the shop, especially the CB and lube technicians that don't need a lap scope. Even your A-level technician, if they don't need a lap scope all the time, this is a good scan tool. It's very fast to communicate with the vehicles, pulls codes quickly, and it's nice and lightweight, but yet it has a big enough display that you can see lots of information. The Zeus is kind of like the powerhouse, 4-channel lap scope, the DB9 connector on top for the pressure transducer and ignition accessories. It's Windows based, but it's a little bit bigger, it's a little more expensive, and it's not always a tool that you want every person in the shop getting their hands on. But I don't always need a 4-channel lap scope. It's not something I use often. Almost always I'm using 1 or 2 channels. This is where the Triton is the perfect tool. Now, one of my other scan tools that I have and I use often is the Modus. I still have a Modus it's probably 5 years old, and I use it often because it's quick and easy to grab. Now these two are corded. They plug into the vehicle, which means they automatically read the VIN. You don't have to wait for the wireless interface to connect. They are very, very quick. But if I hook this up to a vehicle and I'm connected to the internet and I get a code list, that's when the intelligent diagnostic feature comes in. Now we'll plug into this vehicle behind me and do a scan on it, see if there's any codes. Technician did a transmission on this and now it's in my base. I'm assuming there's something else going on with it that we'll have to take a look at. Now both the Triton and the Apollo are a wired interface. So scanner cable plugs into the top of it, you plug that into the vehicle, which means it charges as you're scanning the vehicle. You don't have to wait for that wireless interface to power up. So it's very, very quick. Sometimes a wireless interface like on the Zeus is nice to have, but it also means that you have to plug in an additional cable if you're going to be scanning a vehicle for extended periods of time. I'm talking like a couple hours. If you're having it sit on the vehicle and monitor data, you need to have this guy plugged in, otherwise the battery will go dead. These other guys, they power up through the scanner cable, so you don't have to worry about that. Both of these scan tools have the updated cable that does the Ethernet protocol that the new Volvos and some Jaguars have, and I think a couple other manufacturers are talking about doing. So they come pre-equipped with that from the factory, and it's a new cable specific to these scan tools. Now all of these scan tools can still connect to OBD1 vehicles. So if you're working in a shop like ours here, we still work on a lot of vehicles that are from the early 90s. All of these can still connect to those. There is an adapter cable that goes on the end of the cable, so you can still use all the OBD1 connectors if you have those. Now, if you don't have those and you don't work on them, then you don't have to worry about it. But that was one feature that I did want to make sure worked and that they hadn't taken away, because I personally drive several vehicles that are OBD1, and a lot of our customers bring in those older vehicles because in Colorado, they're still on the road. They haven't rusted out completely. Without making you guys watch me stand here and talk about the scan tool, let's go ahead and plug it into the vehicle behind me and go through the process. So what I'm going to do is I'm going to put the vehicle in the on position. I'm not going to have it running, but just turn the ignition on. I'm going to plug in the scan tool. It's going to boot up and try to identify the vehicle if possible, depending on if the vehicle has that feature. Okay, so the VIN number was pulled up, the odometer was pulled up. I could enter the license plate if I wanted to. All that information will get stored with the scan. Now let's go ahead and hit code scan. So we can see that it has detected a couple of codes already, but it's going to go through and scan every single module. Now, depending on how new the vehicle is and how many modules there are, this could take a different amount of time. Some vehicles I've had down to 30 seconds on a full code scan. Other vehicles take a couple of minutes, depending on how fast the communication is between modules. So 25 systems detected. We have engine code and transmission code. And it says intake air temperature sensor circuit high. Let's go ahead and click on that code. It says turn the ignition switch off. This is primarily a Ford thing. We're going to hit continue. It's going to pull information from the internet related to that code. So top repair is replace mass airflow sensor, clean throttle body, replace engine intake air duct, connected intake air temperature sensor, replace intake plenum gaskets. So just look at this as just a quick view of what some other technicians in the field have done. Don't use this as a guaranteed, okay, I need to do this. If that doesn't fix it, I need to do that, and that, and that, and that. It's just a glance at what has been done in the past and what other shops have reported. There are no service bulletins for that code. If we go to Smart Data, it should pull up a data list related to that code. Now, since it's an intake air temperature sensor, I got to turn the key back on. It's going to give us information related to that code. Now, intake air temp, it's probably only going to give us a couple of data PIDs related to that. They may give us a ambient air temperature sensor, intake air temp. I'm not quite sure. It's going through several different PID lists and determining which data PIDs it should use. Okay, so we have intake air temperature, intake air temp 2, and then we have voltage for both of those PIDs, and then we have intake air temp status. So it says intake air temp is negative 40 degrees. Intake air temp 2 is 75 degrees. And then if we look at our voltage, number 2 is at 3 volts and number 1 is at 5 volts. Now, 5 volts, we had a code for intake air temperature sensor high. That would be indicated by our 5 volts. This typically means that we have a broken wire or an open in our sensor. Now, I went ahead and unplugged this sensor before we started. So this is a common code for a sensor that is unplugged. If I were to plug this sensor back in, we should see the data change and everything will be just fine. Now that I plugged this in, our temperature jumped up to 66 degrees and we were at 3.26 volt. Now, the thing that just flashed on there was it saw a major change in temperature that was out of the normal parameter of what it was expecting to see. Because I had it disconnected and plugged it back in, that sensor jumped 80 degrees. So it automatically saved that scanner movie in the scan tool. So if you were waiting for a vehicle to act up or doing a wiggle test on a vehicle and you had it running, you're wiggling some wires, as soon as it detects that glitch and it falls out of normal parameters, it's going to save that information so you can come back and review it. Now, if you didn't see the data PID that you wanted to see, all you have to do is hit the back button and you can select additional data PIDs. You can go to the pre-selected ones here, or you can do a custom data list. But that one had everything that I needed. Now let's go back again. Say that that sensor was plugged in, but the value was off a little bit and you wanted to use the lab scope to test that. You can go down here to the guided component test meter. Now it does give me two options on engines. This one is the turbo GDI. And it automatically comes up with, at the top, IAT sensor. So it's recommending this test, but it gives you a list of the other tests as well. We're gonna go to the recommended test, component information. It gives us a bunch of information about this sensor. Now, if we scroll down after reading all the information about the sensor, it gives you the best location to test it. And it tells you what color the wires are and what the labeling is. And on a related note, it also tells you where sensor number 2 is located, because it's a little bit different than sensor number 1. So after looking at the component information, we could go to a DC voltage test, and it gives us a chart of what the voltage should be at different temperatures. So even if we have a sensor that is skewed and reading improperly, we can scope it and make sure that the voltage relates to the temperature listed. Now we can also use this information while looking at the data PID on the scanner, but what would be best is connect the scope to the sensor, compare the voltage at the sensor to the voltage that we were just looking at in the smart data. And once again, it tells us where the best connection location is. We click on view meter once we get everything connected, and it's automatically going to come up with a lab scope with the settings we need. So we have 0 to 5 volts because that's all the sensor is going to read. Now I'm not showing anything here because I'm not connected. Our 0 line is right there, but they keep that all the way at the bottom by default because we should be above that. And even if we're in open circuit, back probing that wire, if the sensor is bad, then we'll have 5 volts. Now if we back probe that wire and we see 0 volts, then either we have a bad connection or that wire is broken somewhere between the sensor and the PCM. And we have other related real fixes and the troubleshooter. So if we go into the troubleshooter for that code, it's going to give us additional information for that code, but we saw most of that in the guided component test meter. Now that we've plugged the sensor back in, we could either clear all codes. If we had a whole bunch of like battery disconnect codes because the battery was disconnected while doing the transmission, we could clear all those codes out. I'll actually just go to engine and clear the codes. Now, since the transmission was replaced, it's possible that there is a relearn that we need to do. So if I go to service resets and relearns, we can determine that. They have perform wheel alignment, replace, relearn battery. They have engine stuff, brakes, the ADAS systems, and transmission. So we can reset the transmission adaptives. Now I'm not going to do that because I don't know if the technician has already done that. I don't want to mess up any of his work, but I can see right here that there is a transmission reset, and we replace the transmission. So that's probably the step that I would have taken. If the vehicle was only in for an oil change and I was doing a pre-scan as a courtesy to the customer and to cover my butt, I can also go in here and look. This vehicle takes 6 quarts of Motorcraft 530 motor oil, and it also gives me some warnings about what type of oil to use. And then at the top of the screen, there's 2 buttons for the oil change reset. Now, the button on the left is if there is a reset that you can do with the scan tool. It'll automatically do it for you. If there's not, then you click the one on the right, and it's going to give you information on how to reset that oil light. And some vehicles will have multiple procedures depending on what type of instrument cluster they have. This one actually gives you 2 different types of instrument cluster and what the steps are to reset that light. Let's go back. There is tire and wheel service. This should give us tire sizes, pressures, and torque specs for the wheels. And it even gives us TPS information. So there's a lot of reset information there for the TPMS system. I'm going to click on the tire and wheel fitment, and it says I should have one of these two options, depending on 18-inch or 20-inch wheels, what the inflation pressures should be, what the torque is, and what the bolt pattern is. Now, I didn't know I had the bolt pattern. That could be a very handy feature when ordering replacement wheels. Now, say we're in here looking at the enhanced data on the vehicle, and we're not quite sure what we're looking at. Maybe our reference material is referencing the generic data. Well, from any point on this vehicle that I'm connected to, I can hit the home button up here, and this little sidebar pops up. And I can look at quick lookups. I can go to OBD2, guided component test, scope multimeter, and look at some of my previous vehicles and datas, or I can exit the vehicle. Let me click on OBD2. It'll take me straight over to that screen, so I don't have to go back to the home page and then select OBD2. It takes me straight there. It's a little bit of a shortcut. And then I can look at the generic mandated values for something. Maybe I don't know about the fuel trims. If it's an import and they're displaying the fuel trims in a weird format, I can go straight to generic and compare what is showing me in generic versus what it's showing me in enhanced. So it saves a little bit of time, you know, with that quick menu on the side. And there's all of our generic information. And if we want to go back to the regular vehicle, we can switch back pretty quick. So I hope that kind of helped you guys understand what the differences between these scan tools are. Scanner only, scanner 2-channel scope, scanner 4-channel scope on a Windows-based platform. Questions and comments, put those down below. If there is a specific feature or test you want to see this guy perform, then let me know down below as well. While I have it, I'll try and get that done for you. No promises, but we'll see if we can make it happen. Thanks for watching, and I'll see you next time.